Hi, everyone. Thanks for joining us. We're going to give it another minute or two for other folks to join. This panel is part of Alaska Entrepreneurship Week, and we have two graduate students with us that are going to talk about their journey into kind of developing products and working on the research. Okay. I think we can go ahead and get started. Alaska Entrepreneurship Week is happening around the state of Alaska. There's events in communities across the state. So if you want to learn more, you can just Google Alaska Entrepreneurship Week, and you should be able to find the other events that are going on. And at the end of the webinar, I'll have a couple other events that our office is working on. Firstly, I wanted to take a moment to talk about Rise Up. Rise Up is a grant that supports both Jason and Danielle, our panelists, as well as other work that's happening at the University of Alaska Fairbanks, the University of Hawaii at Manoa, and then 401 Tech Bridge, a division of the University of Rhode Island Research Foundation. The Rise Up program supports developing dual-use solutions to industry and military challenges, as well as communities in each of the respective states. Uh, there's a lot of different elements of the Rise Up program. So if you're interested in learning more about different programs available at the three states, you can search for Rise Up, and then we can also put the link into the chat to our joint website. And then into the panel, thank you both so much for joining us. And I think we can just jump right in if you would each be willing to tell us a little bit about yourself. Jason, why don't we start with you?
Sure, yeah. So my name is Jason Noel. Currently, I'm a PhD student at the University of Rhode Island in the Ocean Engineering Department. So I originally grew up in Connecticut, and for the Alaskan folk who aren't familiar with New England, that's right next door to Rhode Island, so pretty close. Didn't move that far with my undergrad at URI, and then I just kind of rolled over into the PhD program after doing some work in the same lab in my undergrad.
Awesome. Thank you. Danielle?
Yeah, I'm a master's student at the University of Alaska Fairbanks. I'm with the Department of Biology and Wildlife. I grew up in Louisiana, and I like to joke that I have been trying to escape the heat ever since. And so that brought me to the state of Alaska, where it's nice and cool. And I originally was working in musical theater, actually, for a portion of my adult life, and then decided to pivot and go into science. And so I came to UAF, ended up getting caught with the research bug, started working with my advisor also when I was an undergraduate student, and decided to continue that work into a master's program.
Excellent. Thank you. I was wondering if you could each give us a quick overview of your research and technologies, and I included a few photos that you all gave me. So if you wanted to continue, Danielle?
Yeah, sure. So the project that I'm primarily working on now is called DART, Detection of Antimicrobial Resistance Toolbox. And what you're looking at now is a laptop and that little sort of Kit Kat bar or granola bar sized device that's right next to it is a genetic sequencer. And so the idea is that you can take this laptop, this genomic sequencer that's made by a company called Oxford Nanopore, and you can go out in the field and you can test for antimicrobial resistant bacteria. So things that can make you sick and that would be difficult to treat. In the state of Alaska, that's actually a really big issue. Testing is difficult. We have a lot of remote places that don't have easy access to labs. So being able to take out a toolbox like this and test wherever you need to be looking for things that could be making people sick, um, we thought was something that would be very useful and beneficial to public health. So this is sort of our toolbox for addressing antimicrobial resistance.
Awesome. Thank you, Danielle. Jason, do you want to talk a little bit about your technology and research?
Sure, yeah. So the what I work on are very kind of small, compact deployables for deep sea exploration. So we work in the ocean primarily, but there are use cases elsewhere. In my undergrad, I kind of focused on what's seen on the left, which are these kind of small sensors. There's camera, there's lights, there's a CTD on top of that. It's conductivity, temperature, and depth sensor. But the backbone to all of this is what we call fiber optic fishing line, which is a very thin fiber optic cable that has a Delrin, which is a type of plastic woven sheath around it, like hollow core fishing line. So the backbone to most oceanographic exploration is the equipment that you use. That equipment is usually very large, and then that equipment requires an even larger winch with a very thick tether that's attached to it that is then mounted on a over 100-foot research vessel that costs hundreds of thousands of millions of dollars. We tried to kind of approach this issue with a citizen scientist lens. So trying to make technology that you can basically fly anywhere with the world in and deploy it off of any size vessel. So we started initially with boat mounted systems that can wind thousands of meters of this fiber optic fishing line, or FOFL we call it, in a drum about this big. And we could deploy that off of any skiff to large boat. And then what we're trying to do right now as we start commercializing this is actually mounted in aerial fashions, like you see on the right there, where we have it mounted on a drone. The system's called High Dive right now, and we're working in conjunction with Juice Robotics to try to get this out the door.
Excellent. Thank you. I guess I'm curious about how you first kind of were introduced to the research that you're working on now and how you met your advisor and how that whole journey began. So, Danielle, if you wanted to talk a little bit about that.
Yeah, sure. So when I came back to school, I knew that I wanted to go on to med school. And so I was trying to sort of tick boxes for that. And I wanted to get a little bit of research experience, not only to improve my application, but also because I was curious about genetic research and was also sort of maybe thinking about the idea of not only being a physician, but also doing biomedical research as well. And I ended up coming across a workshop that was exactly what I was looking for. It was genomic research, looking at sequencing microbes using that granola bar that you saw in that previous picture, actually, that specific device. And so that workshop was being led by my current advisor, Dr. Devin Drown. And it was a great opportunity for me to not only be introduced to research, but also being introduced to my advisor, kind of seeing what his teaching style was. And it was a great experience. And so that's how it all kind of got started. And the ideas for the project that I'm working on now kind of came out of that workshop. We were looking at using that technology to better detect specific types of microbes, specific species. And then out of that work, we started asking the question of, oh, well, what if we can look specifically for ones that are resistant to antibiotics? If we can apply this to something that is very relevant to specific public health challenges. So yeah, it all really started out of this workshop that happened, I guess, gosh, 4 years ago now. I think it was 2021 or something like that. So yeah, it's amazing what a workshop can do.
Awesome. Thank you. Jason, I would love if you could talk about it, and especially if there's any similarities to Danielle's experience, if you could highlight those or differences.
Yeah. So it's been a bit longer, I guess, than 4 years ago for me, where I got picked up into this. I mean, like going really far back. I've always been on the ocean, kind of around the ocean. I knew that I wanted to try to combine like the love that I have of building things to being on the water in some way, shape, or form. That gets me fishing in really cool places, but also, actually doing some good. But when it comes to actually kind of getting picked up into research, I had no clue that I wanted to be involved in research really until I got to URI. So I started knowing that I wanted to work on the ocean, but not really in what regard. And then my advisor, Brennan Phillips, in my freshman year, which was 2018, gave a really interesting talk at like one of our introductory classes, which with all of the majors. And it kind of inspired me to push towards that ocean robotics track because he was talking about all the cool things that he's seen and like kind of all the places he's been to and how he's explored the ocean. And that really kind of drew me in. So then a year later in 2019, I had him as an actual professor for one of my classes, and I tried pretty hard to keep my name, up there. I was trying really hard in the class and talking to him, and eventually I got the courage to actually ask if I could possibly do research in the lab. And so he took me on as an undergraduate researcher, which was a really cool opportunity. And then COVID happened, but luckily he was a good enough advisor where he kind of held on to me as we went through that. And then by the time I graduated, I really didn't know where I wanted to go in the field. I didn't want to do like the engineering desk job. I kind of really liked what we were doing in the lab. So he convinced me that research was the right route, and I definitely thought that I think that that's been the right choice for me. I started originally with a master's program, but then I kind of transitioned into PhD because I really just didn't want to let go. Um, and now here I am, I guess, 8 years later from when I first was introduced to it, but now 4 years into my graduate studies.
Excellent. Thank you, Jason. Um, I guess I'm curious about the product development of the high dive and the other technologies that you've been working on. What did your need finding process or the process of finding out like what was needed to develop that specific technology, especially as you highlighted like with the citizen science component?
Mhm. So, like I said, with the original system, it was primarily based on being deployed from a boat, but we always had these visions of being able to deploy it off of different technologies. So that initial need and kind of the value we saw is the fact that it doesn't fully replace that huge winch that you can use with these large oceanographic pieces of equipment, but it gives you another option and it lets you explore places that aren't really that easy to get to. So a lot of the work that's been done with the winch has been done in Bermuda, which is easy to get to, but we're able to get to really deep water pretty efficiently outside of there and test our equipment really deeply. But we've also done things like Brennan, before I started, went to like the Pacific Islands, and he did some work there with the reel system. And I've been to the western coast of Panama on a really cool research vessel called the Eugen Seibold to deploy an ROV system from this as well too. So it's kind of interesting that we can use this smaller system to kind of look into these different parts of the ocean without that huge price tag that most oceanographic research has on it. And then high dive came along because there isn't really an easy way to get really rapid data from underwater to land because you have this kind of difference of materials where you can't get radio frequencies or Wi-Fi or anything to penetrate water and then get back to wherever you're controlling it really quickly. So high dive is this drone that has that fiber optic cable mounted underneath it in a spool, so we can unspool the sensor into the water, and you're able to get live feed data collection from that sensor to the drone back to land almost instantly. So that is more interested that it kind of has more interest from the Navy and things like that, but that kind of highlights the dual use capabilities that Rise Up is interested in some of the research that we're doing, because it can also be used in agriculture or renewable energy and things like that as well.
Excellent. Danielle, would you mind sharing what your journey was like in terms of figuring out the needs that the DART system might be able to help solve in Alaska?
Yeah, sure. So when I was an undergraduate student, I was able to participate in an I-Corps program through Center ICE. Ashley was actually teaching that course when I took it, and it was a great experience being able to talk to people. I mean, that's really what it's all about, is just going out, talking to people, and listening. And so, right off the bat, we started having conversations with people from the EPA, from the Department of Environmental Conservation, people in academia that were engaged in research dealing with wastewater and also water treatment, and really trying to not be too descriptive about what we were trying to do, because we wanted those conversations to be really sort of open to whatever their biggest problems were. We wanted to be fulfilling a need. We wanted to be creating a solution to a problem. And so being able to listen to people about what was the number one thing that was causing making their jobs harder. And so we learned a lot about the limitations, not only in infrastructure here in Alaska for wastewater, for waste removal, but also the difficulty in terms of testing in general. Um, so that was really informative. It helped to guide what we were building our tool to do and who we were building it for. I think sometimes there's a bit of it can be overwhelming. There are a lot of different industries out there. There's a lot of different places where we could have sort of explored using this tool, and that's still the case. But figuring out that first sort of, I guess, beachhead market, that first place where you can really be a solution to their specific problem, that was really key for us. And so we sort of honed in on wastewater surveillance of antimicrobial resistance. And so that's where we're focused now. But yeah, I would say it's a really important part of not only research and for a product, but creating solution-based work is just listening to people.
Thank you. Thank
Yeah.
you. I'm curious what tech development is like in your field, Danielle, like if that's common, like in as far as on the research side.
Yeah, I think that's something I'm still learning quite a bit about. When I first started research, the entrepreneurial space, the innovation space felt like something for like, I don't know, business people and startup, like people who are really keyed into business, and like tech bros. Like that was really my perception of this space. Um, but the truth is that the innovation space is a huge opportunity for researchers, not only for getting funding and support, but also being able to see the things that you're doing in your lab go out into the world. Um, so in my research field, there is quite a bit of bioinformatic tool development, and so bioinformatics is data analysis that's specific to biological data. So there's quite a bit of that, and I feel like those are tools that are made by researchers for researchers. There are quite a few people that are involved in biomedical research and so are developing tools for diagnostics for surveillance, which is really more, DART isn't diagnostic, but it is more on the surveillance side. So there are other tools that are being developed in labs like that. Yeah, but it's still something I think I'm learning about. In academia, sometimes we can feel quite isolated from the outside world. And there are folks who are kind of breaking down those walls and really engaging with the community and creating tools for public health. So yeah, still more to learn on my part, but I'm glad to be involved in this space.
Thank you, Danielle. Jason, I'm curious what tech development is like in your field. I feel like the outside perception is often that engineers are often really involved in creating prototypes and design, and I'm curious if it's similar in the subfield that you're involved in or not as much.
Yeah, so there's kind of a dichotomy in the field that we work in, and we even see it with our lab too. So a lot of the times when you see the research of ocean engineering, at least on our campus, there's two main parts. There's the people that do like months to years of simulation work to then develop like one prototype and pretty much be confident that that prototype will work the second you throw it in the water. And then there's the other side that is kind of where a lot of what our lab does is where we call it guerrilla engineering, where we rapidly prototype and we basically make a product from idea to reality. And we've done it up until a span of like a week's time, pretty much. And then we deploy it in the water right after that. It'll probably break, but we figure out why it broke, and then we fix that and kind of iterate on it from that point. But we can do that because we have a pretty unique lab in the fact that we have a lot of different methods of prototyping, and we've done a lot of research on that field too. So we do a lot of additive manufacturing, so 3D printing. Um, but we've actually published some papers with 3D printing companies as well too, to make kind of specific ways of processing these materials to use them in the ocean environment. Which, if there's one really specific thing the ocean doesn't want you to do, is throw electronics into it because they just don't really get along that well. But we figured out a pretty good way to do that at that point. And we have a mobile lab in Bermuda, because my advisor was there for the last year on sabbatical, and we're able to use this basically shipping container to develop those same prototypes and build them and test them within that week span. But then there are other things in our lab that kind of do take that longer approach. So it's really, you find yourself ping-ponging in between these two options, and the major factor in those is money. So if your equipment is super expensive, like the type of sensors you want to use and things like that, you obviously don't want to take the rapid prototyping route. You want to take your time and make sure that you're doing it right the first time. But with these smaller things, especially things that like we kind of want to test like this and eventually get to market, we can test really quickly to see if they do what we want them to do, show it to a customer, get some feedback on that, and then eventually make it into more so of a product than a research project.
Awesome. Thank you. And then I guess speaking of funding, how do you plan your funding applications and budgets? And how did you find out initially about some of the support offered at URI and then also the graduate fellowship program?
So I'm very thankful that my advisor does his due diligence. He's very mindful with the grants that we get. We luckily in our field can get a lot of support from the Navy. We have a lot of funding from ONR, as well as we've gotten NSF and different outlets of funding too. But ONR is nice because it is also what supports us at Rise Up. So I'm kind of dipping from the same pot to do very similar things, but we know that they like that kind of work. And so I'm supported in part from our labs grants as well as the one from Rise Up. And it's definitely kind of huge in the fact that we can really support the creation of this product with that Rise Up grant, but also support the research of it with the ONR grant that we initially got for the lab. And then on my side of things, it's been very interesting kind of figuring out how to manage the funding that I've personally gotten from Rise Up, because I'm used to, the lab pot to pull from, like, oh, we're going on this many trips a year, get ready for this deployment, et cetera. But I am planning that myself with Rise Up. So I'm kind of figuring out how to do that grant management a little bit better by myself with that.
Excellent. Thank you, Jason. Danielle, what has your experience been like?
Yeah, I feel very lucky. When I first started as an undergraduate, I kind of knew, or I realized that every 3 or 4 months we would be writing another proposal to try and get research funding. And I've been lucky that once I shifted over to my graduate studies and became part of the Rise Up program, that there's been a quite bit more stability, especially for funding for my position. It's an unusual position to be in, I think, as a graduate student, to have that sort of long-term support. So that's been wonderful. And I think as far as planning for research funding, I feel like I'm still figuring it out. It's, hey, we got these funds, quick celebration. All right, we know we've already planned how we're going to use this, and let's see how far we can take it before we have to work on the next proposal. So it's kind of a continuous cycle of writing up that proposal, getting funds, doing the work, and then trying to be not ahead of the game or ahead of the ball, but knowing that this is not a permanent thing. That's just in research, you know that the proposal writing is never going to end. But yeah, and as far as budgeting, I owe a great deal of gratitude to my PI, who thankfully is wonderful with budgets and helps to put that all together and helps me to navigate that space and understand that our funds are not infinite. So we have to, yeah, be aware of that.
Excellent. Thank you. I just want to take a minute to encourage any audience members with questions to submit them because we'll have some time at the end where we'd be really happy to answer them. And you can submit them if you're on a laptop at the bottom of your screen in the Q&A box. And then, yeah, thank you. So I think that one of the big differences, because we're here during Alaska Entrepreneurship Week and you both work as researchers, is like one of the differences sometimes is pitching the technology that you've created. And so I'm curious if like being in both of those worlds, like what the difference is in it, if there needs to be a difference in how you've pitched your technology, if it's similar in both spaces, and what you've learned from advocating for your technology and your research in multiple spaces. And then, Jason, if you wanted to start.
Sure. Yeah, so I kind of have a good example from this right now is this past week, our Rise Up put on the tech showcase over at URI, and we invited a bunch of different companies to come and pitch their products, and it was really unique to see because Juice Robotics, the company that I'm working with, also pitched High Dive, and there was a very big difference in how some people pitched to how others did where some you could tell were researchers before they went into the product market because it sounded like a conference presentation. And you kind of are like, oh, halfway through, you know that they're doing good work, you're interested in it, but it's not really like hitting that pitch that you think it needs to. But I think it's really important that people kind of, as you get confident in your product and you're confident in the research that you're doing to turn it into a product, you need to be able to translate that confidence into like a relatively good quick sell. I apologize if I didn't do that earlier, but I'm still working on it myself. But I actually try to work with our other patents to products fellows too, by doing some workshops with pitches and things like that to try to hone in on that because it's such an important part of like kind of making your product is being able to convince someone that your product actually means something. Because if you do, like Danielle and I are doing like years of research on something, and you really want someone to care about it, and then you kind of fumble on the pitch, it feels like it was wasted. But you can always kind of pick yourself up again and retry at it. But yeah, I guess that's how I feel about pitches so far. Be confident and be able to kind of sell your research for what it is.
Awesome. Danielle, what would you say?
Yeah, I totally agree with what Jason is saying that confidence is really key. And there are times where I pitch something, I'm like, I don't know that I really got them with that. Like, I feel like that wasn't my best performance, but there's always another pitch. Like, there's always another opportunity, or hopefully there is. Um, I think that, yeah, talking about our science, or talking about my science in the entrepreneurial space versus in academia, yeah, they're very different crowds. That being said, I think that a lot of the elements that I use when I'm pitching in an entrepreneurial or innovation space, a lot of those elements are really successful if you bring them into an academia sort of setting, or if you're presenting at a conference. Because in academia, there is sort of this expected formula of this was our hypothesis. This is how many, this is how we set up our experiment. Here's our results. Here's our methods. Here's a conclusion. It can be very formulaic. That when you come in and you're speaking story first, hey, this is the problem. This is what it's like to live in Alaska and not be able to perform testing. This is the impact to the community. Wow, wouldn't it be great if we had this product? And really setting a scene for people helps them to get engaged and to understand the motivation underneath the science. At the end of the day, people are people. I think people love stories. They love engaging in human stories. So no matter where you are, if you can put that first and connect with people, they're going to be more invested in whatever you're saying. I think the difference that remains is maybe the ask at the end. So in entrepreneurial space, I'm usually saying, hey, we're at this stage, we're looking for investors or we're looking for collaborators, right? And in a conference setting, maybe that's different. I'm maybe not as blatantly saying, "Hey, we are looking for money," but but yeah, story first. And I think also realizing that even when you're at a conference, that doesn't mean that everyone that's attending is in your field or has like the same sort of baseline knowledge about whatever your topic is. So the broader that you can make it in some aspects, the same way that you would in an entrepreneurial space, that invites more people to listen to what you're saying and go on that journey with you. So yeah, I think pitching and that skill set has really helped me. I think it's very transferable between the two spaces.
Excellent. Thank you, Danielle. And Jason, I could see you kind of nodding along. Did you have any comment or response to Danielle?
Well, my one response is we're scientists. We're always asking for money. I think they understand that when you're pitching at a conference. But no, I totally agree with the fact that like you need to be able to sell the problem before you can sell your solution. That's kind of that's a big part of what we try to teach with our kind of entrepreneurship classes and things like that. Because if you can't make that story believable, because like it's our everyday life, we know that it's a problem. But if you can really impress that onto someone else, I think that's how you really get the point across.
Awesome. Thank you. And then I guess in thinking about the problem and the people that you're hoping that your device will impact or support, how do you consider community impact when you're developing your technology or thinking about the direction that you're going to take it?
Yes, I'll keep going. It's we're really trying to approach that. At least that was the initial goal with our system, is to make it so kind of any community would be able to adopt this and be able to deploy it need be. Because there's a lot of island communities and things like that that have limited access to resources. Even Bermuda itself, it's a great vacation place, but it's very difficult to actually get equipment there. If you ever need a lot of like heavy equipment, you have to ship it over on a very specific boat, and the whole process is very expensive and very time consuming. But we're able to fly there with like, a couple cases and be able to deploy really quickly. And that kind of helps both us out as well as a lot of members of their community too. Because there's a lot of researchers that have equipment or they want to be able to send something in the ocean that can't, because it's either too expensive to get something there or it's just they're going to miss their mark by waiting too long to get something. And I think it's also pretty applicable both in Rhode Island and Alaska, because Rhode Island has such a huge fishing population and everyone has boats and things like that. But a lot of them want to try to get specific technology in the water and still can't because they either don't have that technology or they don't have the means to afford it. So if we're able to make something that's relatively affordable and easy to use for pretty much anyone, we can kind of get that in the hands of those who would need it initially.
Thank you.
I guess I can jump off of what Jason was saying, and it's amazing the similarities of challenges across different places. We're developing DART specifically with Alaskan communities in mind, and I think a huge component of that is the whole customer discovery process and really talking with people and gaining an understanding of how they do their jobs, how and what they would want to see in a solution. I also had the opportunity to go to Honolulu and speak with some researchers and people that were engaged in public health testing there. And it's funny how there are some similarities between what they're experiencing, just because there are all these different islands in Hawaii, compared to what we experience in Alaska. And what's separating people is not water, it's just a whole lot of land and very little sort of infrastructure and road infrastructure. So even if you're developing something for a very specific community, it's amazing how other communities can also benefit, that your tool can be useful in a lot of different contexts. But I do think it's important at the beginning to really zone in and make sure that you're solving a solution, solving a problem for someone specifically, rather than going too broad too fast. But yeah, there can be broad applicability there once you have a solution going.
Thank you. Kind of going off of that, I guess what makes Alaska a unique ecosystem for people, innovators, and people like you that are developing products or solutions?
Hmm. I think there's an incredible, vibrant entrepreneurial and innovation space. This is something that I learned once I had sort of entered the Rise Up program and through my connections at Center Ice. But there are so many. It seems like there's so much interest in startups, in new companies, and there's a whole sort of angel investor community coming out of Anchorage. And I do think Alaska is a special place in that there are unique challenges here. Like there are things that we encounter as Alaskans that you wouldn't necessarily see in the lower 48. And that's just sort of a breeding ground for innovation, right? There's like that saying of basically that, when you have a need, when you have a unique challenge, that breeds sort of creativity, and creative solutions come out of that. So I think that that makes Alaska unique.
Thank you. And then Jason, I'm really curious to hear about what you think makes Rhode Island a unique place for innovators.
So, Rhode Island is definitely special in the sense for my field, it has so much support in it right now for that we're calling the blue economy. That can be anywhere from defense to renewable energy to different kinds of boats or things like that. And it is a massive field right now. Almost any startup that you kind of hear about in Rhode Island currently is involved in the blue economy in some way, shape, or form. And it's unique too because Rhode Island is the smallest state. So I mean, it's funny comparing it to Alaska because I think we have almost the same amount of people in either state, but one is, yay big and one is yay big. So it's really interesting. And to see kind of such a bonded entrepreneurial focus in one state is really unique and also kind of helps us in a way because Rhode Island has this other unique thing where I don't know if this is, the past mob ties or something where everyone knows somebody. So if you talk to someone about your product, then somebody that you're talking to probably knows someone that can help you with it, or they know an investor that's interested in that field, or anything along those lines. So there isn't much competition really, I'd say, in the market, but there's definitely a lot of support because there's so many different unique startups going on right now in Rhode Island that we've only really felt supported in the field so far.
Excellent. Excellent. So I'm going to put you both on the spot if you don't mind and ask if there's like any questions you have for each other so far. I do have some other ones if you want to take time to think about it, but I just want to make sure that there's a chance for you all to ask what you're curious about from each other after spending some time learning about each other's journeys.
I have a question for you, Jason.
Sure.
And this might be a bit of a naive question, but so I know I imagine that Rhode Island water can get pretty cold, water off the coast there. And you
Mhm.
mentioned that you all have a testing space out in Bermuda, but do you think that if one wanted to use your tool, your technology up here in Alaska and like the Bering Sea, or I mean, are there differences there that you think your technology, that it might be a new challenge for the technology, or the technology would work really well? Just thinking about sort of the Alaskan environment and the temperature. Yeah.
So the nice thing about the ocean is a lot of the times when you get deep enough, the temperatures aren't really that different. So it'll be very cold. I mean, if you go a few thousand meters under the water in Bermuda, it's still very cold. So the behavior of the equipment might be different on the surface, but once you get it kind of in the water, it should be, for the most part, okay. You have to obviously account for some sort of expansion or contraction and things like that, depending on what seals your equipment and really what the limitations are of it. You don't want your cameras freezing or anything like that. But for the most part, I think it would work in either place. I mean, heat is honestly really difficult to deal with for some problems because your pressure housings start expanding. If it's just sitting on the deck and you're in 90 degrees, then you start building up pressure on that and it wants to pop open. The opposite, if you're in the cold water, it tries to contract, which actually helps in some regard. When I was in Panama, the water itself was I think over 90 degrees. So our laptops were like frying themselves. All of their pressure housings were trying to open up. The batteries weren't doing well. But then comparison to that is once you start putting lithium batteries in really cold environments, they do really poorly. So it's I think you kind of have to fight it in whichever way you go. It's just something we deal with for the most part.
I see.
Yeah.
Cool.
And I guess for you, do you see a lot of applicability from your kind of process to bring it into other communities outside of Alaska, or do you think it's primarily going to make an impact in a place like or just Alaska?
Yeah, I hope that it can be of use to in other communities. Sort of speaking to the conversations that I had with folks in Hawaii, I definitely think that there's potential for usability there. And then also the fact that transporting samples to a lab can be it can take time and it can be costly. Um, that affects a lot of different places. Also, funnily enough, I got a chance to speak with someone who works with microbial research with NASA. And she was sharing how, when you think about the health and safety of astronauts, like they are literally off the planet. And thinking about sending astronauts to the moon or to Mars, like, funnily enough, same as Alaska, it's going to be really hard to get those samples to a lab for testing to see if they have a resistant infection or if they're surrounded by microbes that can make them sick and not be treatable with what they have on hand. So the idea of DART being able to go to other places, yeah, I'm really hopeful that it's something that can be useful and useful to a lot of people. And if NASA wants to call and acquire Dart or use Dart, I would be quite happy. So yeah,
That would definitely be a cool exit.
yeah, that'd be cool.
Awesome. Awesome. So we have some questions from the audience. So one that I'm seeing first is, do you consider yourself an entrepreneur? If yes, when did you start seeing yourself in that light? Does one of you want to take that first?
Sure. I would say that I am. From a very young age, majority of the people that I know, including my parents and family and things like that, were always like, "Oh, we're not worried about Jason. We'll all be living with him when he's older." Because for some reason they were convinced that I'll be able to make money in some way, shape, or form. But doing that and growing up with that in the back of my mind, I also realized that I never didn't have a job. I kind of always was scrounging around for a different way of like kind of inventing something or making money in some way, shape, or form. That sounds a little shystery, but I mean, and a kid wanted to buy things, so I figured it out. But then when I came to school, I did the same thing where I'm in a bunch of different fields. I'm into art, I'm into metalworking, I'm into woodworking, I'm into engineering and everything like that. So I've always had my hands in these different pots, and I kind of see myself going forward and just kind of being involved with businesses like engineering and maybe others going forward. So I would say that, yeah, I am a entrepreneur and I hope to continue being one.
I think that's a good problem to have, Jason, and having people knowing like he's gonna do well, and we're gonna go and we're gonna chill at his at his place. Yeah, I don't think I'm there yet. Like I don't know that I would call myself an entrepreneur. But there are also days where I kind of struggle with like calling myself a scientist, which is kind of weird. But um, yeah, I think not yet. I think I'm someone who um, I still feel like I'm feeling out the innovation space, and I've been in it for a few years now, but I'm still learning quite a bit. And I do see myself as someone who's always going to want to be engaged in the space. That's always going to want to be developing tools that hopefully are useful to people and improve public health. It's something I feel very passionate about building solutions. Um, and I guess maybe just in my mind, I need to like connect that and being an entrepreneur or like the Venn diagram there is very much like a circle or can be a circle. But yeah, maybe one day I'll have the confidence, but I don't know if I'm quite there yet.
Thank you, Danielle. I guess from what you said, I'm curious what your plans are moving forward with the product and company development, as well as your own graduate student research plan and timeline.
Yeah. So with Dart, we're continuing to support our value proposition. So collecting data to show that our tool does what it is supposed to do. And then hopefully either having it be acquired by another company or potentially seeing if in the future there could be a startup there. But I think right now we're hoping for acquisition. Um, I am planning on defending my thesis and finishing up my master's either in the spring or early summer. So we're getting close to the end here of my master's program, which is pretty exciting. And then after that, I'm pursuing an MD PhD. So I'll be in academia for quite a bit longer, which makes me happy. Um, and yeah, those are sort of my future plans in a nutshell.
Thank you. Jason, what are your plans moving forward for the product that you're working on developing with Juice Robotics and your own graduate plan?
So, my the interesting thing with me, so my advisor, Brendan Phillips, he's also involved with Juice too. So I had to sit down with him the other day where he was like, now don't get carried away as we start going into, industry. Finish your PhD first. So I got that in mind. We're kind of doing it at the same time, but I'm hoping to finish my PhD in the next year, graduate or year and a half ish, graduating in 2027, uh, the spring of 2027. And kind of alongside that, moving forward with Juice and the product as we're getting into the market. So we just had that tech demonstration, which went really well. We got a lot of interest from some funding sources and things like that, and collaborators. So we want to start getting into that first round of either dilutive or non-dilutive funding as we go into the actual business side of things, and then eventually making those first prototypes and getting them out to customers as quickly as we can to try to then start getting feedback back on top of it. So I'm looking at Michael's question. He's saying, how do you split one of them is how do you time the split between your tasks, like science and commercialization? I'm working very heavily on that right now, really trying to focus on how I can split working on this as a product with Juice and then working on my research as well too, because as they're both very similar, they are kind of verging at a certain point because I need to publish and write about certain things that we perform, but we also need to develop and produce a product that we want to sell. So currently, there is no specific method of splitting my time. I'm kind of just doing it off the cuff, but it seems to be working out okay so far.
That's great to hear. Danielle, how do you manage your time between both aspects?
This is such an interesting question, and Jason, I'm so thankful that you shared your perspective because I think that that is something that um, it is a unique thing to be developing a tool while you're in graduate school. There are certain tasks and certain goals that are shared between the two of what I'm doing for my master's thesis and the research side versus the commercialization aspect. But there are also things that are really kind of separate. Um, yeah, I think it's sort of an ongoing question, an ongoing balancing act of what is most pressing right now. Um, and I do think it's challenging. It is challenging, sort of um, being on track, continuing with what you need to get done for your graduate thesis or your graduate research, and doing the commercialization aspect. I don't know that there's a method to my madness. Um, but I guess I just try and focus on making incremental progress on both sides. If every week I'm inching forward in both regards, then I feel like I'm making progress and just take it one week at a time.
Thank you. Um, I think there's another two questions that I think are kind of related. So for you, Danielle, since you're headed to your next step soon, what happens to the commercialization aspect of your work once you graduate? I know you'd spoken about potentially being interested in being acquired.
Yeah, we definitely have interest there. My advisor, Dr. Devin Drown, is also a co-founder of DART. And so even if it's a project that's, well, first of all, after I graduate, I want the project to live on, with my advisor. And then if we're able to recruit someone else as well, I think that would be great. If the technology is acquired, I'm happy with that as well. I think the main thing is that this tool be something that can live on and be a solution, a real living, breathing solution, rather than something that sort of dies when I graduate. Um, so yeah, it's an ongoing conversation. I'm thankful in that I have a co-founder and who's still going to be with UAF and is still interested in this project. And so we'll see what happens.
Thank you. Jason, it sounded like you were potentially interested in continuing to work with the technology after you graduate. Um, what happens to the commercialization aspect of your work once you graduate?
So I think once I graduate, I definitely don't want to completely let go of academia. My advisor and I have tossed around the idea of doing a postdoc, either part-time postdoc or full-time or something, but that keeps me in the role of working on the lab stuff still, as well as giving me the flexibility to pursue the commercialization of this product because we have that unique relationship with juice being so closely related to our lab and using a lot of the lab's IP. I would be able to kind of continue that commercialization while also continuing the research that we're doing in the lab. So yeah, I definitely want to move forward into that commercialization aspect and taking it to like the professional, you know, company level. But I also don't want to fully let go of the research. I don't think it's comfortable. I like doing it, and I feel like it occupies my mind where I don't know if doing like full product development all the time would keep me as content.
Amazing. Awesome. And then I guess to answer another question, Jason, do you have any advice to scientists and researchers who aren't sure if they want to add commercialization into their research?
I think understand if the research, like you want to know your problem first, like we talked about before. You want to make sure that that problem that you're addressing with your research is something that can be kind of expanded on in a commercialization or an entrepreneurial light. So a lot of the times, researchers will focus on a problem, make a solution, publish a paper on it, and then it gets pushed to the back burner. If you feel like the what you're working on is worthwhile, obviously you're working on it, so it should be worthwhile. But if you think that it has more potential in a market or in a commercialized sense, then I think you just have to kind of make the jump and go for it. Make sure that you do the proper steps of making sure you're not stepping on anyone's toes for IP and do your research to make sure that it hasn't been done yet, or there isn't someone currently exploring it, or if there is, reach out to them and see how maybe you can help them as they kind of continue in to that entrepreneurial field. So basically, make sure to do your research first, make sure that the problem has its footing in multiple markets, and then if you're passionate about it, pursue it.
Thank you. Danielle?
Yeah, I guess I would say that I think at some points when I thought about commercialization, the sort of picture I would have in my mind is the path that like Mark Zuckerberg took, right? Where he created this thing, it grew and grew, and then he ended up having to, he left school, like that whole team and that whole company really took over what he was doing in his professional life, and which is a completely valid path, obviously. Um, but it's not the only path. And there are a lot of different ways to be, to commercialize something, to be an innovator, an entrepreneur. It can mean doing a startup. It can mean creating a thing and having it acquired by someone else. It can mean doing a thing and having it live as part of your lab and maintained by the lab. Like there's so many different ways that that story can play out. So um, I guess I would say don't feel as though there's only one way to enter that space, and that if that path doesn't feel right for you, great, there's a million other ones. If you're making something that's useful, that can be useful to other people, why not share it? And I think as a researcher, the reality is we're always looking for funding. We're always looking for ways to support our research and our positions. Um, the innovation space, the commercialization space, is a great way to look for research funding and to be supported. There's so much money that goes into innovation, and especially right now where our options for federal funding seem to be shrinking. It's nice to have this other space that you can engage with and get research funding for. So yeah, I would say I would encourage anyone who has any interest to check out commercialization and entrepreneurship for sure. I have been very lucky in the amount of support that I've gotten, and it's because of entering the space and being curious about it.
Awesome. Thank you both. I think that's an amazing note to end on. And I just want to thank you both for taking the time out of your busy schedules, balancing these two big responsibilities on top of your many other roles, and take a moment to just share the other events that Center Ice at UAF is leading at for the rest of this week. So there's one in-person event at the UAF Makerspace. That is from 7 to 8 p.m. in Fairbanks. And then we have two more webinar events that you can join from anywhere. I'd really encourage you all to check that out or check out any of the other events in the link that I just shared. Yes, so thank you everyone for your time and have a great rest of your Tuesday.
Thanks, Ashley.
Yeah, thank you very much. It was